Hello and welcome. Are you somebody looking to achieve one of the highest grades possible in GCSE maths? If you are, then please continue watching this video on percentages and more specifically the multiplier method if you are looking to achieve, like I say, one of those highest grades possible. Now, as always, we will be calling upon your prior knowledge and previous understanding. This video is no different. To be more precise, we will be looking at your conceptual awareness of what we refer to as compound percentages, or conversely, simple percentages, but then also your ability to multiply by decimals and actually your use of a scientific calculator, just to save that little bit of time in an exam so you're working as efficiently as possible when you're feeling those time pressures and time constraints. But like I say, if you're somebody looking to achieve one of the highest grades possible in GCSE maths, please continue to watch. Let's start by taking a look at question 1. A car costs £18,000. Its value increases by 5% each year, year on year for 3 years. Find the value after 3 years. Now, straight away, I would argue this is a strange question, because normally when you buy a car, they don't appreciate in value, they depreciate in value. Not always. So I'm only going to assume that somebody's bought a rare vintage car, perhaps, that is an investment. In other words, it's going up in value, but it certainly isn't the norm. This would not normally be the case. But nevertheless, that's the question we've been presented with. So let's start tackling it. I'll just scroll down to give myself a little more space. Okay, so our starting value is £18,000. I'm just going to begin by writing that down, like so. I've said we're using the multiplier method, hence I've started straight away by writing down a multiplication symbol. The value increases by 5%. Our multiplier value for 5% is 1.05. Please don't think it should be 1.5, that would be 50%. But it's year on year, in other words, compound for 3 years. So I've got to multiply it by 1.05 3 times, like so. Now, for the purposes of this video, I've shown this in detail, but actually what you should be more familiar with is the following style of notation. 18,000 times 1.05 in brackets to the power 3. The power representing the time frame of the question. In this case, 3 years. But it could equally be months. It could equally be hours, just depending on the context of the question. Well, all that's left now is to get your scientific calculator at the ready and start typing away. And I always recommend getting familiar with your scientific calculator long before the day of any exams, because they all work slightly differently. But in my case, I'm going to start typing 18,000 times, in brackets, 1.05 close brackets, to the power 3. Execute. I have to change the format of my answer to a decimal. I am getting 20,837 pounds. And what's quite nice about this answer, I don't have to worry about any rounding off, because the answer on my calculator display is already to 2 decimal places. Again, one exam tip to remember: if the units in your question relate to money, come what may, your answer has to be to 2 decimal places. But in this case, like I say, the calculator display is already at 2 decimal places, so we don't need to round. Let's start looking at question 2 then. A laptop costs £900. Its value decreases by 15% each year, year on year. So the year on year, giveaway, compound. Find its value after 3 years. Now, this is far more realistic with new tech always entering the market. Again, it's very rare for a laptop to go up in value. More often than not, nearly always, in fact, they will decrease in value. Now, this time, because we're looking at a decrease, if we have a decrease, if I just write this down, if we have a decrease of 15%, hopefully everybody will agree we have 85% left. The reason being, of course, percentages are out of 100. Now, I'm going to begin in exactly the same way. And I know I said I won't show the full working out anymore. I will just on this occasion, just so everyone becomes clear and hence more confident. So my starting value times, on this occasion, because it's a decrease, it will be 0.85. How many years? Just rereading the question, 3 years again. So times 0.85 times 0.85 times 0.85. But I am going to write this correctly. I say correctly in the shorthand fashion. This would give you the right answer, of course. So I should write 900 times 0.85 and again to the power 3. Calculator at the ready. 900 times open brackets 0.85 close brackets to the power 3, execute. Again, I've got to change the format of my answer. And this time, whilst I've already written the units in preparation, my answer is £552. I do need to round off. On this occasion, 71 pence. And that's question 2. So question 1, we looked at something increasing in value. Question 2, something decreasing or depreciating in value. Let's look at question 3. A jacket is reduced by 30%. The sale price is £56. Find the original price. So I'm just going to begin. A reduction of 30% means we have 70% left. Now, I'm actually going to show you 2 methods on how to solve this question, and then you can decide which one resonates with your understanding better, more effectively. I'm just going to call our starting price X. And if we reduce our starting price by 30%, that means I must multiply it by 0.7, as we've looked at here. And we're told that the sale price is £56. Well, now very simply, by our knowledge of equations, we can say that X equals 56, the inverse of multiply by 0.7 would be to divide by 0.7. Therefore, X equals, again, take your calculator, just get familiar with it, 56 divided by 0.7 equals £80. Now, I did say I'm going to show you an alternative method, so I'll do that in a different coloured pen. If we've reduced something by 30%, we have 70% left. So we could argue that 70% equals 56. And we can treat this like a ratio almost. If we divide both sides by 7, like so, that would tell us that 10% is worth £8. Now, the original price is worth 100%. So once we have our 10% value, we could multiply each side by 10, and that will give us 100% equals £80. So I suppose the method in blue sticks to the multiplier method, and the answer in maroon, the approach in maroon, is a more common sense approach, looking at values. Like I say, a lot depends on your preferred method of working out, and also how you've been taught at school, because I'm certainly not here to confuse you. I'm here to try and add clarity. Let's take a look at question 4. Let's just scroll the page down. Question 4. A company increases the price of a product by 25%. Later, it reduces the new price by 20%. And the final price is £240. Let's look at part A first. What is the original price? So if I just write A here, just for that clarity, so we don't get anything confused later on when we're looking at things. Our starting price, again, I'll begin with X, is increased by 25%. So initially, I need to multiply by 1.25. But then we reduce the price by 20%. If I reduce something by 20%, I have 80% left. So that would need multiplying by 0.8. For clarity, I'm just going to write the 0 in just for that, for no other reason than so you can see where the percentages are coming from. And we are told that the final price is £240, like so. This would most likely be on a calculator paper, so don't take anything to chance. It's not a difficult question to do in your head, but let's use a calculator. 1.25 times 0.8 equals 1. I wonder how many of you had already realised. So to get our starting value, X equals 240 over 1. Therefore, the starting price was indeed £240. So in other words, they've had an item. Perhaps that item has become high in demand, so the shoppers thought they'll cash in on it for a short while. They'll increase the price. But then as that demand has fallen, they've lowered the price again back to its original price. So the original price is no different to the final price. But for a short time, it had an elevated price. And like I say, one of the main reasons for that is because that item is in high demand. Part B. The overall percentage change. The starting price, the final price, they're identical. There hasn't been any change. The overall percentage change is 0%. Now, as always, if we have touched upon any topics in this video that you think you might need further support with, please check out some of our other videos. But in the meantime, good luck in your quest in order to achieve one of the highest grades possible in GCSE maths. And thank you for watching.